So assignment number 70. So you kind of start the same way. You set it equal, and I don't know how much room we're going to have. Yeah, we'll probably have to do it on our paper, people. Let me get a sheet of paper. So we're going to do the same thing, 3x squared. I'm going to put the 11x right by it. I'm going to leave a space. And then I'm going to put that negative or the constant to the other side. And I honestly didn't have to do that. Okay. All right. And then what you're going to do is you are going to divide the whole thing by your coefficient of the x squared. You're going to divide it by, what number is that, by the way, anyway? That is number 10. All right. So you're going to divide it by 3, divided by 3, divided by 3. And then we've got 3x squared plus 11 over 3x is equal to 4/3. And then we start doing the same thing that we did yesterday, which is we take our b coefficient, and we take, what do we do with that b coefficient? You take half of it, and because I can't really divide that by 2, I'm going to go 1/2 of the 11 over 3, and I'm going to square it. So that is going to be, I'm adding on both sides, 11 over 6 squared. Oh, wait a second. Nobody caught my mistake. Nobody caught it. The 3x squared. Yeah, because if we divided through that shouldn't be there. So that should not be there. Anyway, so on this one, I'm going to add that to both sides. So I'm going to add that here, which is 11 over 6. And I'm not going to square it here. But over here, I'm going to go ahead and undo it. So 11 times 11 is 121. 6 times 6 is 36. And then, believe it or not, this creates our perfect square. In fact, if I had undone it, if I had undone this, it would have looked like this. So my perfect root would have been 11 over 6. So that's why I just left it. So you can go ahead and, so this is x plus 11 over 6. But on this side, you need to get all of this together. So I need to get a common denominator. Does 36 go into that? I don't think so. No. So I'm going to multiply this one by 12 and multiply this by 12. So that's going to give me on the bottom, it's going to give me 36. And on the top, I'll go ahead and do it right here. That's 48. That's 48 and 121. Which comes to 169. And then guess what you have to do? Take the square root. And by the way, if I did do x plus 11 over 6 times x plus 11 over 6, my middle term would come to that. Believe it or not, it will. But I'm not going to do it. So we end up with x plus 11 over 6 equals, again, plus minus, which I forgot to do. So is there a perfect root to 169? 13. Over 6. And then I need to move what? Then we're going to move this over. So it becomes a minus 11 over 6. So this time, because there's so much going on, I'm going to go ahead and separate these. So one answer is positive 13 over 6 minus 11 over 6. And then the other answer is going to be negative 13 over 6 minus 11 over 6. So what do you think the first answer could be? This takes up a lot of space. It's going to be 2 over 6, and then, well, I guess we'll reduce it in just a second. 2 over 6. And then the other one is going to be what? They're the same sign, so we're going to sum those. So is that negative 24? Negative 24 over 6. And then we'll finish it up right here, and we'll put, it doesn't matter where you put your answer, I'll put it right here, where I have some space. So this one is the 1/3, and this one is the negative what? What is that going to be? And I hope this is correct. I don't have a clue. Oh, she discovered it. Yeah, flip it over. Yeah, there's no sense of us doing these and getting the answers wrong. We need to know right away that we got them right. So Yahoo, got that one right. So the final one is here. And I still have to look up why it says or. I would have thought I should look it up right now, but I'm recording so I can't. All right, so let's do a couple more, and then we're going to figure out how many. I'm going to do one that ends up with a square root. Yeah, the number 14. I'll tackle the number 14. I don't know how it's going to come out, but it doesn't look like it comes out pretty at all. So that one is. So what do we have to move on this one? Yeah, so in fact, I'll start it here so we can save some room. So we're going to go 3x squared minus 6x equals the negative 2. And then what was the second thing we had to do? Oh, and I forgot to put this answer. So our final answer, we can put it right here, is 1/3 and negative 4. And then what's the next thing we have to do? Has something to do with your x squared. Not quite yet. Has something to do with this.
Oh, no.
We have to divide it by that front number. So divide everything through. And then once we do that, then I'm going to bring it over on the paper. Now I'm running out of room. So when we divide that through, I'm going to divide it through and then leave a space to complete the perfect square. So it's going to be x squared minus 2x space equals negative 2/3. And then we do it again like yesterday. What do I do with the b coefficient? We take it in half, so it's going to be a negative 1 squared. So if I add it to both sides, in fact, I'll go ahead and put it. It ends up being, what's a negative 1 times a negative 1? It's going to be a positive 1, and over here it's going to be a positive 1. But by the way, because, do I need to make it in thirds? I think so. Because it's a positive 1, and I need to add it to this, can I put it, instead of 1, can I put it 3 over 3? Does that make sense? So it's still a 1. And then this now has the perfect root. It has a perfect root of 1. It has a perfect root. So we can go ahead, in fact, can we do this all at once? Who knows what's going to be inside this right here? X minus 1. And then over here, it's going to be 3/3 minus 2/3 is going to be 1/3. And then, what do you have to do then? Take the square root, take the square root, and then, so we have x minus 1 is equal to the square root, the plus minus square root of 1/3. However, what's wrong with this side? You generally don't leave something with a square root on the bottom. So we have to rationalize the denominator. Do you remember us rationalizing the denominator? Yeah. So you rationalize it by going a square root of 3 over the square root of 3. So this becomes, now I can combine these. This is 1 times 3 is square root of 3. On the bottom, that would be 3 times 3 is 9. It would be square root of 9. So it comes out as a what? It comes out as a 3. Plus minus. And then I have to get rid of that negative 1. So what do I do? Move it to the other side as a positive 1. So I don't know if they're putting the positive ones in the front. I don't know what they're doing. They are. They're putting the 1 in front. Okay. So we'll do the same. So our x value is equal to 1. Do you think instead of writing it twice, I could just put plus minus square root of 3 over 3? Will that work? So what do we have? So yeah, 1 plus square root of 3 over 3, 1 minus square root of 3 over 3. It's the same thing. So this is 1 plus minus how many are left? Oh, where's mine? What happened to mine? This is 1 plus minus square root of 3 over 3. Okay. And we'll do, maybe we won't finish that one from yesterday. Is that okay if we don't finish it from yesterday? And we'll just work on this one here. Alrighty. So let's see, let's look at another one that's kind of funky. Is the number 15 right next to it? Okay. So again, what do we have to move first? Yeah, so we're going to move that over. So 9x squared minus 36x is equal to a negative 31. And then what's the second thing that we have to do? Go way to the front. Divide it by 9. And then I'm going to bring it over on my paper. So 9 divided by 9 is going to be 1. So it's going to be that number 15 is x squared minus 4x. Leave a space to complete the square. Equals negative 31 over 9. And then, CJ, what would you do next? There you go. So take the negative 4 divided by 2 and square it. So that's going to be negative 2 squared. And what's a negative 2 squared?
4.
Is 4. So I'm just going to put and it's going to be positive 4. And this is going to be a positive 4. I put it real light because I'm going to change it. In fact, I'm going to change it right now. It's going to be 36 over 9. Like I can go 1 times 9, 4 times 9. 36 over 9. So we're at the point that we can go ahead. We've created our perfect trinomial. So who thinks they know what this is going to be in here? X minus 2, such that I did, if the inside was 2x, a negative 2x, and then another negative 2x, it would be 4x. And then on this side, it comes to 36 minus 31 is 5 over 9. And then, Mirel, what's the next step?
Use minus 4.
Very, take the square root. Take the square root. And so this comes out as x minus 2 is equal to, who knows what this is going to be? Oh, and I forgot my plus minus. Yes. So I can put them in their own separate little houses here. Square root, square root. So this one has to stay in his little jail cell, but this guy is perfect, and he comes out as a 3. Plus, minus. And then let's bring that 2 over as a positive, and I think we're done. So our final answer would be, because they're putting the, I guess, the positive numbers in front, 2 plus or minus square root of 5 over 3. And again, if I really needed to see where I needed to graph that, I would find out what the square root of that is, divide it by 3, and then add it, and then subtract it from the 2, or vice versa. But I think that's it. Let's double check. Is that it? Yes, it is. Okay, good. So we're done with this one, we're done with that one, we're done with that one. I keep losing my paper. So this is going to be the 2 plus minus square root of 5 over 3. 10 less than 3. Oh, we should do that word problem. 10 less than 3 times the square, but not a 0. I think we should. Let me double check the time, and then we'll make the assignment easy. Okay. Let's see if we can tackle this. I haven't read it. I don't know what to do, but we'll try. Is the lengths of the side of the squares are increased by 5. The new area is 39 inches. What was the original length of the square? Does anybody want to help? Help? I need help. So the original is x, each of those sides. And then they're giving me the new area. But what did they say the new sides were? They're going to be what? They're going to be increased by 5 on both of them. Well, how do you find an area? Length times width. So here's our length, and here's our width. So on this number 20, we would have to go x plus 5, the length, times the width, x plus 5. And they told me it was 39. Actually, I think this is going to be easier than I think. I think this is going to be easier than I think. I think it is. Why is that going to be easier than I think? Who knows why? That's what I'm thinking right away. Because we've already got, that would be a perfect trinomial if I multiplied it together. So I don't think I need to do anything, except we'll try it. X plus 5 squared. Is there anything perfect in 39? That's 3 times 13. No. So 39. Could it have? No, I don't think so. 25. I don't think so. So we'll just do the way. And then what would we do? Take the square root. Take the square root. Is it looking like the answer on the back? Is there a 39 in it? Okay, good, good, good. Right. So again, x plus 5 is equal to positive negative 39. And then what do we have to move? The 5 and put it over here. And I think we're done. In fact, yeah, if I really wanted to know that side, I would have to go ahead and find the square root, which that would be close to, I believe it's going to be a little bit over 4. So, oh, wait a second, hold on a second. If I have the two answers, one of them could be a positive, oh, here we go. Something doesn't make sense here to me. Positive 39 minus 5, or the other one could be a, oh no, this is, I'm saying 4. The root of this would be about a 6, or it could be a negative 39 minus 5. Who knows one of the answers that it cannot be?
Negative.
Can't be, because you can't have a negative side. So on something like this, you have to think about it. You cannot have a negative side. It could not be that one. So I'm going to flip it over, see what it was. And I think that, yeah, the length of the side cannot be negative. So it is only this one. Because if I undid that 39, it's going to be 6 point something. So that is it. That wasn't that hard. Let me look at our time. Okay, we might as well see if we can tackle the other word problem. And then we'll decide what to do. Okay, and so that's going to be the positive square root of 39 minus, oops, sorry about that, minus 5. What was the original? Yeah, that is our x value, our original x. Then on this one, and if you need more paper, there's more paper over there. So, which numbers are possible? 10 less than 3 times the square of a number. How would you write that? Here's the word then. So whatever follows that has to go first. 3 times the square of a number. Do we know how to write that? 3 times the square, very good, the square of a number. There you go. Okay, and then what, CJ?
Minus 10.
Yes, you saved yourself. Very good. And then, so we already had 3 times the square of a number and 10 less than that. Equals 0. And that's not factorable, so we're going to do it by completing the squares. So I can move that over. This doesn't seem like it's going to come out at all. How could this be possible? Equals a positive 10. And then what do I have to do with the 3? Now this one I don't know what to do. You'll decide. I think I do. Okay. Because I'm thinking I have no b, but I don't think we need it. Divided by 3, divided by 3. So n squared is equal to 10 over 3. And then what do we need to do then? I have no middle number, but can I just take the square root? That's what I'm thinking. But I could be thinking wrong. I don't know. Okay. Plus, minus. But what do I still have to do? Because that 3 isn't a perfect, we have to rationalize the denominator. So n is equal to plus minus. The top number is square root of 30 over what number? Is over 3. Okay. Now, which number? It says, oh, we have to check it. We have to check it. So we would have to put it back in here. It says, which numbers are possible? I could check it using the back, but I want to see if that's what they want me to do. All right, on this one, if I checked it, do I want to do that? You don't have to write this. We'll just figure this out together. So 3 times this squared. What would this be squared? Would that be 30 over 9? Square root of 30 times square root of 30 does not take the 30 out. So 3 over 1 times 30. And this would come out as a 9. I hope this is going to come out. And then what can I reduce? Oh, that's going to be, is that 90? Oh, that's it. Equals 10. And is 10 minus 10 0? Yes. So that answer is correct. Will it come out the same if I put a negative here? Yeah, it's going to come out the same. So I think it should be both. And is it? Yes, those are our two numbers. And that is it. Okay, people. So we've done quite a few. We have conquered quite a few. So this is square root of 39 minus 5. This one was plus minus, I just lost it, plus minus square root of 30 over 3. And then how about you all tackling, and this is your only job, 11, 12, and 13. Can you handle those? I think you can handle those. And you can even work together. And that is